2, we have a piecewise function that's x squared over absolute value of x for x not equal to 0, and 0 for x equal to 0. Alright, and we ultimately need to let f be a continuous function defined above, and we want to know what is the value of the integral from -4 to 2 of f of x dx. So let's think about what this picture will look like here. So if we were to plot some points here, we can figure out hopefully what this looks like. So we have our 0, 0 here, we know is a point. So anything not 0 here, and again keep in mind we're only concerned about -4 to 2 here, so let's just say we put -4 in for argument's sake. If we were to put a -4 in here, we'd get 16, and a -4 in here would give us 4. So we get -4, 4 would be our result. So if we went 1, 2, 3, 4, 1, 2, 3, 4, -4, 4 would be that one. And then if we did -3, we'd get 9 over 3, which would be 3. If we put -2 in there, we get 2. And if we put -1 in there, we get 1, so on. So ultimately our expression would look like that. 0, 0, of course. Can't have 0 on the bottom, that's why they define 0 to be 0 here to make it continuous. And if we put a 1 in there, we get 1 on top, 1 on bottom. So we get 1, 1. 2 in there would give us 4 over 2, which is 2. And that's really all we need then, isn't it? Alright, so bottom line here is that it turns out that these are just 2 line segments. So to find the area, don't we just have a couple of triangles? So again, we want the area from -4 to 2 of our function. So this triangle is 4 by 4, so 8 on that one. This triangle is 2 by 2, 2. And ultimately we should get 10, which is letter E. Questions on number 2? What else? 1 through 5. And number 4, we have a radius of a sphere is increasing at a rate of about 2 inches per second. How fast in cubic inches per second is the volume increasing when the radius is 10? Well, ultimately we have things that are changing with time. So it sounds like a typical related rates problem. They give us the radius is increasing at 2 inches per second. Okay, so that would ultimately be dr dt, if you will. That's how the radius is changing with time. So 2 inches per second is our dr dt. And we want to know how is the volume changing. In other words, what is dv dt in inches cubed per second. So identifying those variables, etc., knowing that we have a sphere, then that means our formula is 4/3 pi r cubed. And so once we have our equation that relates the 2 variables that we have, in this case there's only 2, so once we have that equation we can differentiate with respect to time, and we'd get dv dt over here. Over here we get 4 pi r squared dr dt. And ultimately we know all the information that needs to go in here. We know the radius here is 10, and the dr dt is 2. So with that we'd have 800 pi inches cubed per second. Corresponds with letter D, looks like. Questions on number 4? What else? All right. Anything 1 through 5? Anything else in the 1 through 5 group, Jeff? 3. 3 gives us a problem that gives us an integral from a to b of c of s ds, and the c stands for fuel consumption of car that's measured in gallons per mile. And the question is, what are the units on the integral? Well, again, just keep in mind that if I were to draw this c function, the units on here are gallons per mile. So if I were to integrate this, I'm going to be finding the area under the curves, right? So ultimately my units then would be gallons per mile times miles. So ultimately what would the units be? Gallons then, wouldn't it? Okay. What's that? make it, I thought S was miles. S is miles per hour. So if it's miles per hour, then the miles would cancel out, and we give gallons on top, hours on the bottom. Okay. So again, just to relate the units in terms of the Y units and the X units, the area is always going to be the X's times the Y's. So whatever these are times these are is going to be the units on the integral. So S was miles, S is miles per hour, S is also a rate. What else? 1 through 5.
On number 6. Oh, wait, you just did that.
What?
Wow. Sorry.
Anybody else 1 through 5? Okay, number 6 then. On 6 we have a table that gives the function f and its derivative at selected values. If the derivative is continuous on 0 through 5, the question is what is the value of the derivative integral from 1 to 4? So in general, if I were to want to handle this integral, I'd need to find an antiderivative for f prime. So what would be an antiderivative for f prime? F. Remember, all we need is n antiderivative. So if we have a definite integral, the antiderivative here is just f of x, evaluated at 1 to 4, so ultimately it'll be f of 4 minus f of 1. And from our table, what's f of 4? 2. What's f of 1? -5, so ultimately the answer is 7. Questions on number 6? What else? 6 to 10. Go ahead. Number 8, we have an integral 1 to 3 of x and x squared plus 1 dx. And if you look at that, that's not a known derivative. So if it's not a known derivative, then we need to try something else. We could use substitution here because x squared plus 1's derivative is related to x. So if we let that be our u, if you will, our du then would be 2x dx. And we have an x dx to get rid of here. So in our substitution, we could write it as 1 over u. And we'd have 1/2 du would be our x dx. So we could replace the x dx with 1/2 du. And our integral would look as such. And if we took the antiderivative, we have the natural log of absolute value of u, because it's just a linear down here. So it's not a power function. So with that, we could have 1/2 natural log of absolute value of x squared plus 1. We don't really need the absolute values at this point because we have x squared plus 1 can't be negative anyway. Alright, and with that, if we put our 3 in there, we're going to get 1/2 times natural log of 10 minus natural log of 2. And you'll notice that that's not an answer because this is where they test if you know calc or pre-calc work or not. Okay, what can we do with the natural log? If we have a natural log of subtraction, that came from natural log of the division of the arguments. So therefore we'd have 1/2 ln 5. And is that an option? Looks like choice D. So the question is, are there any pre-calc questions on the AP test? No, but can they test if you know anything about pre-calc by putting answers in multiple choice like that, where you need to use some of your pre-calc knowledge to manipulate the answer and get it in the right form? A lot. What else? Right. And 7, we have a slope field here, so take a look at the slope field. We have and it's in y, of course, here. We get expected it's from y because if you notice that the rows are all uniform. Okay? As we go down the rows, they have the same slope. So that's a feature of a differential equation that has y only. Okay? Remember, if it's x only, it would be in the columns, it would be the same. And if it's in x and y, then they could be anything. Okay? All right. So bottom line here is which statement is true about their function, and the statement number 1 says if y 0 is greater than 2, then as x approaches infinity, then y is equal to 2. So in other words, and again, keep in mind this y of 0 is equal to 2. If our y value is greater than 2, okay, if our y values are greater than 2, then the limit is 2. Well, let's look here. Here's 2. And if we look at the stuff that's greater than 2, as we go to the right, what seems to be happening to these curves, they get it closer to this, what kind of line? They get closer to a horizontal line, and the horizontal line happens to be 2, just like it says, isn't it? Okay. So would this be a safe bet then? Alright, then let's take a look at this one. This one says if it's between 0 and 2, if we're looking at the y values between 0 and 2 here, then the limit as x approaches infinity is 2 also. So if we look at between 0 and 2, the slopes here are essentially fairly flat. They get a little steeper, a little flatter here. Does it appear that they approach this horizontal asymptote too? And then finally, what about the bottom one? When we're less than 0, do the values approach the value 2 also? Okay. Yeah, if we're less than 0, what do the values seem to be doing as we go to the right here? Values continue to go down, don't they? They don't approach 2, do they? And when we're less than 0, when we're below the x-axis? Okay. So ultimately 3 is out, so therefore the only 2 that are in are numbers 1 and 2, so it should be D. What else? 6 through 10. Number 9, we have the derivative of ln of 1 over x squared minus 1. So we're just got to find the derivative. So what do we know about natural log in general? The derivative of natural log of u is 1 over u times the derivative of u. So 1 over x squared minus 1 would be our natural log part. And then we have to multiply that by the derivative of the argument here. And I'd probably write the argument as x squared minus 1 to the negative 1. That way I can use the chain rule. So if I differentiate that, I'd have the following. And simplifying all that, we'd end up with a negative 2x on top, and then x squared minus 1 all squared on the bottom. And again, that goes here. So we're multiplying by the derivative of the argument. So simplifying this, I'd have x squared minus 1 times negative 2x over x squared minus 1 all squared, which means that could go along with that. We'd have negative 2x on top, x squared minus 1 on the bottom. And question is that an answer? And if not, does that mean we're wrong immediately? Not necessarily. So ultimately, if you made the top positive and the bottom negative, it would look like that, wouldn't it? And ultimately, multiplying top and bottom by negative 1 over negative 1. So we could change the form of it and make it look like that, and then it would correspond with the right answer, which is B. What else? 7 through 10. Okay. Number 10, we have from 0 to pi over 2, an antiderivative of 2 tangent x's. And ultimately, if we want to do the derivative of that, we're ultimately going to do the integral from something to something. And ultimately, again, we're looking for an antiderivative here. And so if we want to anti-differentiate tangent, remember the technique for that is to write it as sine over cosine. So that way we can let the bottom equal cosine. The du then would be our negative sine x dx. So negative du would be our sine x dx. So that's what our setup will look like with our use substitution. Tangent's typical use substitution problem because if we write it as sine over cosine, we can substitute that, and that's nicely part of our derivative. And so therefore we're going to get negative 1 over u du as our substituted integral. This cosine is the u. Sine x dx is equal to negative du. So here's your negative, here's your du. Get rid of our sine x dx. negative natural log absolute value of u plus c. And we do negative natural log of absolute value of cosine x plus c. And we look at our choices, we don't see that as an option, do we? So again, pre-calc, and where can this negative 1 go? Go on the exponent of the cosine, which makes our argument cosine to the negative 1. Well, what's cosine to the negative 1? Secant. So we ultimately have natural log of secant x plus c. Alright, and so bottom line is if we look at the choices we have there, okay, which choice is that? Yeah, you're right. Sorry, we still have 2 out here. So 2 here, 2 here, 2 here, 2 here. So ultimately we have not only a negative but also a squared. So it's actually secant squared. Yeah. So we have a negative 2 out in front.
Wait, how do you make the 2 over negative secant squared?
Because ultimately if I have the natural log of ax, that's the same as natural log of x to the a. If I have a power, I can bring the power out in front, or if I have something out in front, I can put it back on the power. It's one of my 3rd rule of logarithms. Okay. So if I have a negative 2 out in front, I can put that on the cosine. Remember, if I have cosine x all to the negative 2, that means 1 over cosine x to the 2, which ultimately 1 over cosine squared is the same as secant squared. Anything else on number 10? Anything else? 6 through 10? 11 to 15?
Wait, what happens to the negative side?
The argument's now cosine x to the negative 2, so that's why we put it on the bottom. That's how it becomes secant instead of cosine. Put that, makes it go on the bottom. Negative. 11 to 15?
11.
On 11 we have some charts here. It says the function is continuous on closed interval 4 to 6, twice differentiable on the open interval 4 to 6, and it says if the derivative at 5 is negative 3 and f is concave down on the given interval, which of the following could be a table of values for f. Okay. So if we look at our, the table of value choices we have here, ultimately it says that the only thing we know about our function is that it's twice differentiable, so it has a derivative. We know that the derivative at 5, which is in the middle, is negative 3, and we know that f is concave down always. Okay. If we look at the point options there, we have, if we look at choice A, let's say we have 4, 8. So let's say that's our 8. So 4, 8. We have 5, 4. So that's halfway. We have 6, 0. Okay, ultimately, that if we plotted those points, wouldn't those be linear? Okay, so even though if we did the slope between those endpoints here, we get 0 minus 8, and then 6 minus 4. Wouldn't that be negative 2 anyways? Okay, we know the derivative at 5 has to be 3. Okay. All right. So bottom line here is that this can't be the correct choice. If we look at the next choice, we have 4, 8, and then 5, 6, and then 6, 2. So if we're to plot that, we have 4, 8, 5, 6, and then 6, 2. And notice that it went down only 2 here, but then 4 here. So this would be kind of a curve that would seem to be reasonable for concave down at least. So we'll keep that one in the running for the time being. If we look at the next one, we have 4, 8, and then we have 5, 6, and then we have 6, 5. That one goes down less the second time, so that would be a concave up situation. Okay, so that one's out. And then if you look at D, D goes down uniformly again, 6, 4, 2. Okay, so that one's no. And then how about letter E? You got 4, 8, you got 5, 3, and then 6, 2. Wouldn't that be kind of the same thing we just did here? Goes down 5 and then only 1. So that would be more of a concave up situation. So really, this one would be the right one. The other giveaway on that it's B is that if we did 2 minus 8 and we did 6 minus 4, we'd get negative 6 on top, 2 on the bottom, which would be negative 3. And remember, the mean value theorem guarantees that if the slope between the endpoints is -3, then the derivative at some point also -3. It would be at 5 at this particular case. So choice B would be the one. What else? None? And 12 says we have the line tangent to this curve at x equals -2 is y equals x plus 4, and we want to find the value of k. So we ultimately have the curve kx plus 8 over k plus x. And at the point x equals 2, we have the equation for the tangent line. So in other words, in this particular case, we know that y prime at -2 is equal to 1 then, don't we? Wouldn't that be fair to say? Because the derivative is 1, because the slope of the tangent line is 1. Okay. So we know that is true. And bottom line here is we want to find the value of k. Alright. So we know something about the derivative of our function at this -2 point. So if we were to find the derivative of this, our y prime would be, if I do k plus x, the bottom, times the derivative of the top would just be k, minus the top, kx plus 8, times the derivative of the bottom would just be 1. Okay. All over k plus x all squared. Okay. And so on the top we'd get k squared plus kx, and then we get minus kx minus 8 all over k plus x all squared. And notice that the kx's will cancel out on top, so we'll be left with k squared minus 8 over k plus x all squared. Now remember, this is the derivative, right? And we know that this equals 1, but it equals 1 when x is equal to what? When x is equal to -2. So if I do k squared minus 8, I do k plus -2 all squared equals 1. Then I would ultimately have an equation that has just k in it only, which is good. I want to be able to solve this for k. So if I multiply both sides by k minus 2 all squared, and I distribute it here, foiled if you will, I'd get minus 4k plus 4. And conveniently, when we try to put these together as a quadratic, the k's squareds cancel out for us. So we're going to wind up with -8 equals -4k plus 4. If we subtract, we get -12 equals -4k. Divide, we get 3 equals k. So again, key issue is recognizing that we, by being given that tangent line at a particular point, we know the derivative's value at a certain point. So if we could find the derivative, set it equal to 1 at that particular point, then the only variable then is k. So that's just a matter of doing some algebra and solving for k. We're good to go. Jeff?
You guys said it equal to the slope at that point?
Yeah, ultimately the derivative is equal to 1, so the slope of the tangent line is the derivative. So since it's y equals x plus 4, we know the slope is 1. So therefore, at -2, we know the derivative equals 1. So that's why we put a -2 in for x and 1 in for the derivative. Other questions on number 12? What else? 11 through 15. And number 14, we have another group of options here. It says that the function has a vertical asymptote at x equals 2. It says the derivative of f is positive for x not equal to 2, and it says which of the following statements could be true. So the derivative is positive, keep in mind, we know that we have an asymptote here. So if the derivative is positive, it says that the number 1, that the limit as x approaches 2 is infinity. Okay, let's deal with 2 and 3 first, because remember 1 is going to be a result of 2 and 3, so let's see if we can determine whether 1, 2, or 3 are correct. The limit as we approach 2 from the right is positive infinity. Let's see if that could be the case. If we had the limit from the right, could it be positive infinity? What did they tell us about the derivative of f? The derivative is positive. So is this positive derivative? No. So what does that tell us about number 2? It's out. Okay. What about 3? As we approach 2 from the left, could it be positive? derivative, right? So 3 could be good. Alright, knowing that that can't be a fact with 2, wouldn't 2 have to be more something like this? Approaching from the right? Positive derivative? Okay. Derivative is always positive except at 2. Okay, so it had to be something like this. So what does that tell us about number 1 then? Is the derivative, or is the limit as we approach 2 in general positive infinity? No. Positive to the left, negative to the right. So that means there is no limit for 2 itself. So therefore 1 is out. So the only choice would be 3. Letter C. What else? 11 through 15. 15 says, which of the following statements concerning the location of an extreme value of a twice differentiable function of f are all true? Or it says they are true, I should say. And the question is, which statement also includes the correct justification? So, in part A, it says the function has a maximum at x equals 5 because f prime at 5 is equal to 0. Okay. So, question is that legitimate to say that?
No, it could be a minimum.
Says, which statement includes the correct justification? So again, if we say that there's a minimum at x equals 5, is it going to be okay for us to say it's the reason is because the derivative is equal to 0 there? Is that enough information to show that it's a maximum? No. That would make it a candidate for a maximum or a minimum or neither. True. But not enough information. How about part B? It has a maximum at 5 because the derivative to the left of 0, or the derivative is less than 0 for x less than 5, and the derivative of the derivative is greater than 0 for x greater than 5. So bottom line is in that part B, they're telling us that there's a maximum because to the left of that point the derivative is negative, and to the right the derivative is positive. So the question, does that make a maximum? That makes a minimum, so that one's no good. How about part C? The f has a minimum at 3 because the tangent line is horizontal there. That still doesn't tell us whether it's a minimum or not. Okay. Could be a maximum or a flat spot there. How about part D? That f has a minimum at 3 because to the left of 3 the derivative is negative, and to the right of 3 the derivative is positive, is what that notation indicates. So would that be fair to say? That would qualify as a minimum. And why is E out? If we have a minimum at 3, because the second derivative at 3 is negative, if the second derivative at 3 is negative, what would that indicate? That would indicate concave down. If it was concave down, then that point wouldn't be a minimum. It would be a what? It would be a maximum. Second derivative test. So the only one with a legitimate conclusion would be letter D. What else?